We go over vector practice. In the first one, given the points P, Q, and R there, find the dot product of PQ and also RQ. So before we even get to solve this, we first need to find PQ, and this is simply equal to Q minus P. And here Q, we can see is the vector 2, -1 and 1, writing it in a column matrix form, and then P, that is 1, 2, 3. So if we get to subtract this, we are going to subtract like terms, those x coordinates together, y coordinates together, like that. 2 minus 1, that is a 1, -1 minus 2, that is a -3, 1 minus 3, that is a -2. So we can as well write this in vector form in this manner. So that would be the same thing. Or I can say this is just equal to I minus 3j minus 2k. All these are expressions in which we can write them. Now the other thing that you need to find is RQ. For RQ, it is simply Q minus R. And the Q here is 2, -1 and 1, minus R, and R is 1, 2, and -4. Getting to subtract this, we've got 2 minus 1, which is a 1, -1 minus 2, which is a -3, 1 minus -4, which is a +5. So now we perform the dot product. Therefore, PQ dot RQ is going to be equal to first PQ, that is 1, -3, and -2, performing a dot product with RQ, which is 1, -3, and also a 5. So this will give us, we'll multiply x coordinates together, y coordinates together, and sum them. So 1 times 1, that is a 1, plus -3 times -3, that is a +9. And then plus -2 times 5, which is a -10. So 1 plus 9 minus 10, this is going to give us a 0. So that is the dot product for that one. Now the next one we want to find is PQ times PR. Of course, PQ, I just want to keep it like that. So this is now part B. We are again going to find PR. And PR, for it to be found, we need to first take R, and then we are going to subtract P. And this is going to be equal to our R, that is 1, 2, -4, minus our P, which is 1, 2, 3. And this is going to give us 1 minus 1 is a 0. 2 minus 2 is a 0, -4 minus 3, that is a -7. Now, this is a cross product. We can see there is a cross there. This is a dot product, and these mean different things. So for a cross product, PQ multiplied by PR, we are going to make a matrix. So here we're going to put IJK, and we first get the first one, which is PQ, which is there. We're just going to get the values 1, -3, and -2, putting them down these. So 1 is going to be under I, because that is an x value. -3 is going to be under J, that is a y value, and -2 is going to be under K, that is in the Z axis. And then for the PR, we are going to also write 0, 0, and -7. So I'm going to just find the determinant of this matrix, and the simplest way I can do it is I can use this last column to find the determinant. So we know that to this one we're going to attach a positive, to this one we're going to attach a negative, to this one we're going to attach a positive for us to find the determinant. And so that is going to give us, if we get 0 and then we get the determinant of the matrix which remains, we remove this, we find the determinant of this. Now notice that 0 multiplied by anything will still give us 0. So for this one, the first one and the second one, they'll all be 0. So I'll just write the last one, which is -7. If I remove the row and the column where negative 7 is. The matrix which remains, that is this matrix here, I now find its determinant. So that is I times negative 3, that will be negative 3i, minus 1 times j, that is just a j. So this will give us negative, okay, negative 7 times negative 3, that is just going to be a positive. So it will be a positive 21i and then a positive 7j. So that is going to be the answer then for that one. Now, the other question on this part, I want to find the area of the triangle. The area of the triangle PQR. Now, if we say this is a triangle PQR here, and we know the angle here, any angle that we know, just get this side, and then multiply by the sine of the angle here. That is all we do when we are finding the area. So we can get any two sides. We can either get PQ and PR, or we can get RQ and also RP. We can just get any two sides, or we can as well get this side and also this side. So just any two sides, we are going to get those, and we are going to use the cross product. Now, firstly, I'm going to get, let me get PQ. PQ is going to be equal to Q, which is 2, negative 1 and 1, minus P, which is 1, 2, 3, and this is going to give us 2 minus 1, that is a 1, negative 1 minus 2, that is a negative 3, 1 minus 3, that is a negative 2. And then we also have, we can get any, we can get QR, and this is just R, which is 1, 2 and negative 4, minus Q, which is 2, negative 1 and a 1. So we get to subtract this 1 minus 2, that is a negative 1, 2 minus negative 1, that is a 3, negative 4 minus 1, that is a negative 5. Okay, like that. Now, to find the area therefore of the triangle ABC, this is PQR, is just going to be equal to half, and then we are going to take the modulus of the cross product of PQ and QR. That is what we are going to do. And so this is going to be half the modulus. Now we want to perform the the cross product of these two vectors. And so how do we get to perform the cross product? The cross product of this one is just taking the determinant of these two matrices. So the determinant, we are going to first get I, J, and then K. For PQ, we are going to get the numbers 1, negative 3, and negative 2 there. That is a 1, negative 3, and a negative 2. And then for QR, we're also getting negative 1, 3, and a negative 5. Okay. Now we get now to find, this is going to be 1 over 2. And then what is the determinant of the matrix which is inside there? So first get I. We remove the row and the column, so that is I. If we remove this and this, the matrix which remains here, we find this determinant. That is going to be negative 3 times negative 5, which is just 15, minus 3 by negative 2, which is a negative 6, so this becomes positive 6. And then we use negative j. If we cancel out the row and the column, we're going to remain with these elements. So 1 times negative 5, that is going to be a negative 5, minus negative 1 times negative 2, that is going to be a positive 2. And then plus k, 1 times 3, that is a 3 there, minus negative 1 times negative 3, that is a positive 3. And so this is going to give us 1 over 2, the modulus of 15 plus 6, that is a 21i. This is a negative 7 times negative j, that will be positive 7j. So now what we have there is we're going to take its modulus. So what we are going to have is 1 over 2. The modulus is simply the distance. So that is 21 squared plus 7 squared. And this is going to give us 1 over 2. Of course, 21 squared, that is 441. And then plus 7 squared, which is a 49. This is going to give us 490. And we know 490 is the same as 49 multiplied by 10. The square root of 49 is a 7. So this is going to be 7 over 2 and then square root of 10. This is area, so its units is squared, whatsoever the unit. Let's consider the next question here. Given the vectors u, which is 2i minus j plus 2k, v, which is ai plus bk, and then you've been given the cross product of u and v, and that is I plus ck. Now I want to find the values of the scalar products a, b, and c. So let's first multiply. For part a, we multiply u and v by the cross product. We know when we want to perform the cross product, we're going to put I there, j there, and k there. Now we get u. The number in front of I, that is a 2, we put it there. The number in front of j, that is a negative 1. Number in front of k, that is a 2. If we go to v, the number in front of I, that is a. The number in front of j, we don't have any j there, that is a 0. The number in front of k, that is a b. And so the determinant of this is going to give us, because I've got a 0 here, I can take advantage of that 0 to use this row to find the determinant. That saves on time. So I'm first going to get a, remove the row and the column. So this matrix which remains, I find its determinant. That would be 2j minus negative 1 times k, that would be now positive k. And then if I use this one, I'm going to get a 0. So I'll just go direct to this one. And it is going to carry a positive sign because it carries a positive, this one negative, this one positive. So it will be positive b. I cancel the row and the column. I'm going to find the determinant of the matrix which remains. Okay. So multiplying this one and this one, that is going to give us negative I. And then minus, we are going to multiply this one and this one. That is going to be 2j. And this will give us, we are going to distribute, this will be 2aj plus ak, and then minus bi, then minus 2bj. Okay, like that. Now I'm going to put the like terms together. Those which have got i's, I'm going to put them together. Those with j's, I'm going to put them together. We see that the only thing with an I is that one, so that would be negative bi. Those with j's, I've got this and also this. I'm going to put those together. I'm going to factorize, so that would be 2a minus 2b, and then put a j like that. And then those with k, I only have a, so that is going to be a k like that. So this is the cross product u times v, and we've been given that the cross product u times v is equal to that. U times v is also equal to I plus ck. So I'm going to start equating the coefficients. The coefficient of I, that is negative b, it should be equal to the coefficient of I in here, which is a 1. The coefficient of j here, that is 2m minus 2b, should be equal to the coefficient of j here, but we don't have any j, so that is 0. And the coefficient of k, that is a in the first, should be equal to the coefficient of k in the other one, which is a c. So that is going to be it. And so let's find this. We've already found from here that our b is actually equal to negative 1. And we'll come in the second one here. Of course, 2 and 2 cancels out. So a is going to give us, I'm going to take b the other side, a is going to be equal to b. So that means a is also equal to negative 1. As we can see, you can also see that a is equal to c. So that means c is also equal to negative 1. So a is negative 1, b negative 1, c negative 1. Alright. Now for question b. Find inside form the cosine of the angle between u and v. So the vector u is 2I minus j plus 2k, and then the vector v, we're going to substitute the values of a and b. We've found negative 1, so the negative 1I minus I1j. So the ones will not appear anywhere. Now to find the angle, we're going to use the definition of a dot product. From the dot product, we find that cos theta is equal to a dot b divided by the magnitude of a multiplied by the magnitude of b. And so this will give us cos theta being equal to a, that is 2I minus j plus 2k, multiplied by the dot product of b, which is negative I minus j, and then divided by the magnitude of a and b. So the magnitude of a, that is going to be 2 squared plus negative 1 squared plus 2 squared, and then square root the value there, multiply by the magnitude of b, which is negative 1 squared plus negative 1 squared, giving us cos theta being equal to the component of x here. Will multiply it with the component of x there, that is going to give us negative 2, component of j with the component of j, that is going to give us, that is going to be a positive. Okay, that is going to be a positive. Actually, we don't have j in the other one. This was supposed to be a k here. We don't have any j, so this is a k. So when we multiply j with the other one, that side is going to be a 0 because we don't have n. And then a 2 multiplied now with a negative 1, 2k multiplied by negative k, that is going to give us a negative 2. Why? Because k times k on the dot product, if you multiply the same thing, it gives you 1. That is why when you multiply this by this, it's going to give us negative 4 k squared, but k squared is a 1. And then divided by 2 squared, that is a 4 here. This is a 4 also. This is a 1. So we've got 4 plus 4, that is 8 plus 1, which is 9. And the square root of 9, that is a 3. And then we also have 1 squared, which is a 1. So square root of 1 squared plus 1 squared, that is a square root of 2. And so we're going to find that cos theta is going to be equal to negative 4 divided by 3 root 2. If we want, we can even conjugate, but this is in sad form. This is the cosine of the angle theta. If you want to conjugate, multiply by root 2 down and also on top by root 2, and that is going to give negative 4 root 2 on top over 3 root 2 times root 2. Root 2 times root 2 will just be 2, and these 2 can go there, 2 can go there, and that will give negative 2 over 3 root 2. So we can also leave it in that way. That is also in sad form. And now considering C, we want to find the magnitude of the vector which is perpendicular to both u and v. Well, to find the magnitude of the vector which is perpendicular to both u and v, we just need to perform the cross product of u and v. The vector which results when you multiply, if you've got a vector like this and then another vector like this, this is our a, this is our b. If we perform a cross product of these two vectors, we're going to get a third vector which is c, and that will be 90 degrees to the 2. So this is the vector that we need to find which is perpendicular to the 2. And how do we get that? Performing the cross product. So that is u times v is equal to I j k, and then our u, that is number in front of I, that is 2, negative 1 and 2. The number in front of I, here it is a, but we found the value for a, negative 1. We don't have any k there, so the number in front will be 0. And then b we also found negative 1. And the determinant of this, I'm still going to use this portion because I've got a 0 to simplify my working. I'll first get a negative 1, find the determinant of the matrix which remains, which is that one there. That is going to be 2j plus k. And then I'll go to negative 1, find the determinant of this matrix here. And that will be negative I minus 2j. So this is going to give us negative 2j minus k plus I plus 2j. Adding the like terms, 2j and 2j will cancel there. So just going to remain with I minus k. Now, we want to find the magnitude of the perpendicular vector. So this vector which we have gotten here is the one which is perpendicular to both u and v. What is its magnitude? Just take the magnitude like that. So therefore this will just be 1 squared plus negative 1 squared. Just get the coefficients and then square root. And that is just going to be the square root of 2. That is the magnitude. Let's consider question 3. The angle between the vectors a, which is I plus j, and b, which is 2I plus j plus tk, is pi over 4. Find the possible values of t. Now we know that cos theta from the dot product is a dot b divided by the magnitude of a multiplied by the magnitude of b. And so we have cos the theta here is pi over 4, and that should be equal to a, that is I plus j, and then dot b, that is 2I plus j plus tk, and then divided by their magnitudes. Magnitude of a, that will just be 1 squared plus 1 squared, and then we get to square root that. The magnitude of the other one, that will just be 2 squared plus 1 squared. We're just going to get the coefficients in front of I, j, and k. We square them. And so cos pi over 4, this is cos 45, it is 1 over the square root of 2. And this should be equal to, we multiply I with I there, that is going to be a 2. Multiply j with j there, that is going to be a 1. We don't have any k in here, so that will be 0 times the k there, so that will just be 0. And then divided by 1 squared plus 1 squared, that is the square root of 2, multiplied by the square root of 2 squared plus 1 squared, that is a 5, and then plus t squared. These two things in the denominator are the same, they can cancel out. So we're going to have 1 is equal to 2 plus 1 plus 0 is a 3, divided by square root of 5 plus t squared. This is over 1, we can cross multiply, and we're going to get the square root of 5 plus t squared is equal to 3. Squaring both sides, we are going to get 5 plus t squared is equal to 9. Taking 5 the other side, that is going to give us 9 minus 5, which is a 4. So therefore t is equal to 2, or t is equal to negative 1. I mean negative 2, if we square root both sides. So those are going to be the possible values of t, either positive 2 or negative 2. Now find a vector which is perpendicular to both a and b for each value of t found. So for the value of t, we are saying that the vector a is equal to I plus j, and then the vector b is going to be 2I plus j plus, where there is t, I'm putting a positive 2, and then k. Now to find the perpendicular vector, we need to perform the cross product. That gives us the perpendicular vector. So a multiplied by b is equal to, we write I there, j there, and then k there. The number in front for the vector a, number in front of I, that is 1, j, that is 1, k, we don't have those, 0. Number in front of the I, j, k in the other one, we have got 2, 1, and then 2. We find the determinant of that. So that is going to be equal to get first I, we remove the row and the column, the matrix which remains, find its determinant, and then we go to negative j. Always to this one you need to attach a negative sign. We remove the row and the column, the matrix which remains, we find this determinant to be 2 minus 0. Then we go to positive k, remove the row and the column, the matrix which remains, we find this determinant. And so this is going to give us 2i minus 2j and then negative k. So this is a vector which is perpendicular to both a and b when t is equal to 2. So for t is equal to negative 2, we can try out this one. All we do is, where there is 2 here, where there was t, we're going to replace now negative 2. So this is going to be negative 2, and then we find the determinant. Consider a parallelogram ABCD in which AB is equal to K is equal to A and AD is equal to B. Now let's consider a parallelogram. So if we have got, parallelogram is simply a quadrilateral where two sides are equal. I mean where two sides are parallel. So we have got this side parallel to this one, and then we have got this side parallel to that one. So let's say this is A, B, C, and D. And we've been told that AB is A. So this is going to be A. And then AD is B. So this is B. Now, if this is the case, these two sides are parallel. So they are considered equal in magnitude. And these also, they are parallel. They are also equal in magnitude. So now the first question, we want to find AC. This one here, from A direct to C. So how can we move from the point A and then go to the point C? Well, what we can do is we can move first from the point A to the point B, and then from the point B to the point C, or we can move from the point A to the point D, and then from D we can now go to C. So those are the possible routes that we can take, and we are going to reach to the same value. So part A, first to find AC. AC, we are saying we first move from A to B in this direction, and then from B to C in that direction. So AB, we can see that is a small a, and then BC, we can see that is small b, vector B. Now also if we want to find BD, BD, that is the vector in that direction. Now how can we move from B to D? We can either take this, we first move from B to A, and then from A to D, or from B to C and then from C to D. Any of those two vectors are going to lead us. So we are saying BD is going to be equal to, we first move from B to A and then from A to D. Now notice that the arrow is going from A to B. So if we move from B to A, then this vector is going to be negative. So that is going to be negative A plus, now A to D, that is just a B. We can as well write this as B minus A. So that is the same. Alright. Now for the second question, assuming a scalar product of vector distributes addition, show that A plus B dot B minus A is equal to the magnitude of B squared minus the magnitude of A squared. So starting with A plus B dot B minus A. When we are performing the cross product, it follows distribution as they've told us there. So A times B, that is going to give us AB, and then A times negative A, that will be negative A squared. We go to B, B times B, that is going to be B squared, and then B times negative A, that will be negative AB. You can see that this one and this one cancels out. So this is simply negative A squared plus B squared, which we can also write starting in the positive one as B squared minus A squared. So what we are talking about is these, which we can see here, are simply magnitudes of A and B, which we are getting to multiply. So even here, this is the magnitude of A, and then this is the magnitude of B squared. So those are the terms the same terms which we have. Okay, all right. So let's look at now question C. If b if the magnitude of b is equal to the magnitude of a, what would you conclude for rhombus a b c d? Now if this side is the same as this side, then that means even this side is the same as this side. A parallelogram where all the four sides are the same is called a rhombus. So this would be, you can conclude this is a rhombus. Alright, question number 5. Given the points A 2, 0, 0 and B 0, 1, 1 and C which is 1, 2, 1, find the area of the triangle ABC. Now, how do we get to find the area of this triangle? We have been given 3 points. Well, just as we said earlier, if you've got a point here, a point there, and a point there, you can get any 2 points first. You can get this point and this point. So this can be AB and then AC. So you can get any 2 points and work with them. Now that you've been given A, B, and C, first let's find AB. And we know that AB is simply B minus A. We can write this in vector form. B here is 0, 1, 1, and then minus A, which is 2, 0, 0. And if we get to subtract this, 0 minus 2, that is a negative 2. 1 minus 0, that is a 1. 1 minus 0, that is a 1. And then we can get BC also. And BC is simply equal to C minus B. And our C here is 1, 2, and 1. And then our B, that is 0, 1, and 1. And this is going to give us 1 minus 0, that is a 1, 2 minus 1, that is a 1, and then 1 minus 0, that is, 1 minus 1, that is a 0. That is going to be it for that one. Now I want to find the area. And we know that area of triangle ABC is simply going to be 1 over 2 multiplied by the magnitude of the scalar product of AB and BC. That is going to be it. And so this is going to be equal to 1 over 2. We have got the magnitude. This is representing distance. But for the scalar product, we just need to determine the determinant of AB, BC. So we have got I, J, and K. For AB, we are going to get the values. We've got negative 2, 1, and 1. And then BC, we have got 1, 1, and 0. This is the determinant, and then the determinant we're going to find its modulus. Alright. Now, before we even get to do that, we need to identify a portion which is going to be much simple. I've got a 0 here. So I'd rather use the last column to find my determinants. And so this is going to be 1 over 2 determinant. I'm going to start with a 1 here. 1. If I remove this column and this column, the matrix which remains is this one which is here. I find this determinant. So that is a j minus a k. And then this one I attach a negative there. So that would be negative 1. Remove the row and the column. The matrix which remains has got these elements. So I find their determinant. That is going to be I minus positive minus negative 2k. So it just becomes positive 2k. The last one is a 0 there. So I don't even need to find the determinant because it's to give me 0. Now what I have is j minus k minus j. Okay. This is not a j, this is an I. This is an I here. Minus I minus 2k. We can proceed, and this is going to give us 1 over 2. We add the like terms. First we have negative I, we have got positive j, negative k, and negative 2k. That will give us negative 3k. And this is going to be equal to 1 over 2. We get now the modulus of that. That is going to be negative 1 squared plus 1 squared plus negative 3 squared. And that is going to give us 1 over 2 square root of 1 squared is a 1, 1 squared is a 1, 3 squared is a 9. So we have got 9 plus 1, which is 11. So this is going to be the area, units squared. Now, question B. Show that the vectors u, which is equal to 2I minus j plus k, and also v, which is equal to negative I plus j plus 3k are perpendicular. Now, we know that from the dot product, a dot b is given as the magnitude of a multiplied by the magnitude of b, and then cos theta. Now, for perpendicular vectors, the angle between them is 90 degrees. The cosine of 90 is 0. So this portion is going to be 0. So what we want to show is a dot b equal to 0. So we're going to get u, which is 2I minus j plus k. Multiply that by the dot product with negative I plus j plus 3k. And that should be equal to 2I multiplied by negative 2. That is going to be just negative 2. Just multiply like terms. Negative j multiplied by positive j, that will be negative 1. Positive k multiplied by positive 3k, that is going to be a positive 3. Now, negative 2 minus 1 plus 3 is a 0. So, hence shown. The other question, find the work done by the force F, which is equal to 3I, and sorry, this is supposed to be a positive 3I plus j plus k in moving an object from the point A, which is 2, 0, 0 to B, which is 2, 1, 1. Now, how do we find the force? We know that first, how do we find work? We know that work is given by force times displacement. Now, the displacement here, we've moved an object from this point to this final point. So we just find the difference. Displacement is equal to final position, which is 2, 1, 1, minus initial position, which is 2, 0, 0. And this is going to give us 2 minus 2, which is a 0, 1 minus 1, which is a 1, 1. I mean 1 minus 0, which is a 1, 1 minus 0 again, which is a 1. So this is the displacement. So we'll just get the force. Now the force is given in position vector form. I can as well write it or express it in this form. So what we are doing is we are getting the dot product or the force and the displacement to give us the work. So the force we have got 3, 1, because there's a positive there, that will be positive 1. And then perform a dot product with 0, 1, and 1. Well, we are using the dot product. If you use the cross product, what we are going to find is not a value. You will not find the constant. What you are going to find is another vector. So we get to use the dot product. 3 multiplied by 0, that will be 0, plus 1 multiplied by 1, that is a 1, plus 1 multiplied by 1, that is going to be a 1. So it's going to be 2. Now we know that force is in Newton. So if this displacement was in meters, that would have given us a Newton meter. And so a Newton meter, we know that it is equal to a joule. So that would have been 2 joules. Find the unit vector that is perpendicular to both A, and the A is a 3I minus 6j minus 4k and b, which is equal to that. A unit vector perpendicular to both of these. First, we need to find a vector perpendicular to A and B. And that we can only get it by finding the cross product of the two vectors. So we have I, j, and also k. We get 3, negative 6, negative 4, and then negative 3, 2, and negative 2. Finding the determinant of this, we have got I. Negative 6 times negative 2. If we remove the matrix, which remains is this one. That's the one we are finding the determinant. So we have got 12 plus 8. And then we go to negative j. We remove this and this. So the matrix which remains, we have got negative 6 minus 12. And then plus k, we are going to have a 6 minus 18. So this is going to give us 30i. We have got negative 6 minus 12, that is negative 18, times negative j, that would be positive 18j. 6 minus 18, that is a negative 12k. So this is a vector which is perpendicular to both a and b. Let's name it as vector c. Now I want a unit vector. So the unit vector here for this one is going to be equal to the vector itself divided by the magnitude. And that is 30 squared plus 18 squared plus negative 12 squared. So if you have got a length of 40, you divide it by 40, what you are going to get is a 1. A unit vector is a vector with a magnitude of 1, and so just get the vector itself and then divide by its magnitude. And that is going to give us, we have got 30. What is the lowest number that can go into 12, 30, and 18 without a remainder? That should be 6. So 6 into 30 should be a 5i. 6 into 18, that is a 3j. 6 into 12, that is a 2k. And then if we find the value of what is in the denominator, that is going to give us 13,068. 1368. Okay. So I can just get to simplify that value which we have. If we divide the value by 6, we are going to get 228. Okay, not really by 6. Let's divide it by 36. We are going to get 38. So this value is the same as 36 times 38. And we know that the square root of 36 is a 6. So what we have is, on top we have got 6 multiplied by 5i plus 3j minus 2k. And then in the denominator we have got the square root of 36, that is a 6, and then square root of 38. So this 6 and this 6 is going to cancel out. This is just going to give us 5i plus 3j minus 2k divided by the square root of 38. So that is going to be it for this one. Okay, let's look at another question here. Given that a is equal to 3i minus 2j minus b minus k, b is that and c is that, find the angle between a